Hello there, this is Ms. Page. In this lesson, we are going to learn how to solve quadratic inequalities. And this relates to some of our prior knowledge where we learned how to identify intervals where a polynomial function is either positive or negative. So remember that here's our x-axis and here's our y-axis. And so where a function is positive means that that piece of the curve is above the x-axis, which we see here on this section. So this is a positive section, and over here on the far right is a positive section. And then where a function is negative, it is below the x-axis, which would be this middle section here. It's negative. And then where the function is positive or negative describes the x values that correspond to those positive y's or negative y's. So for these positive y's, the x's that correspond or produce these positive y's would be these x's, which would be x's that are to the left or less than 2. Or over here also we have more x's that have positive y's with them, and these are to the right, so they are greater than the 0 of 4. Intervals, remember, go from left to right, least to greatest, and sometimes involve infinities. These do. So this interval would go from negative infinity to 2 for x. And that's in union with this interval. It starts at 4 and goes all the way to the right for x, which is our positive infinity for x. Where the function is negative is this middle section. When we write an inequality that's bounded for x values that are bounded by two outside numbers, 2 is the smallest number in this interval. So we start with the 2, and 2 is less than all the numbers in the middle, which are our x numbers. And then the x number is also smaller or less than the 4 because it's to the left of the 4. So 2 is the smallest, so 2 is less than all the x's in the middle, and the x's in the middle are also less than 4. So notice we have 2 less than symbols there. And the interval is just bounded by the 2 and the 4. No infinities in this one. It starts at the 2, stops at the 4, and that's all we get for that interval. So 2 inequality pieces, 2 interval pieces, or in this case 1 inequality and 1 interval. So how this relates to what we're doing today, which is learning how to solve quadratic inequalities. Quadratic inequalities, quadratic means that our highest power of x is x squared, and inequalities means that will involve a less than or a greater than symbol, and in this case less than 0 or greater than 0. So here we're looking at greater than 0. And if you haven't yet mastered differentiating between less than and greater than, I would recommend you add to your notes. This is a trick that I was taught in school. Our less than symbol looks like a capital L, and the word less starts with an L. So L is for less. That's your less than symbol. And then your other one that doesn't look like an L, that's your greater than symbol. So here we're looking at greater than 0. Numbers that are greater than 0 are positive numbers. So once we figure out where our function is positive or negative, we match it. So we can see here's positive, here's positive, here's negative. And so this would be telling us that our solutions to this inequality are the sections where those y values are positive. And so we have these x's and these x's, which are shown here also. So this is for positive, this is for positive, this is for negative, and so we have this section and this section. And so this is x's, the left section is x's that are less than -2, or on the far right we have the solution of x is greater than 2. and then the intervals that go with it. And then the middle section, that goes with this inequality. So this one now, it's still the same function, still x squared minus 4, but now we have less than 0, and numbers less than 0 are negative numbers. So that tells us the solution here is this negative section in the middle, and that's what we're looking at here. And that is from -2 to +2 in the middle with its interval notation. So I am going to show you guys two different ways to figure out this little x-axis positive negative situation. One is to use some calculations. The other is to be able to graph a parabola, and you have to know whether the parabola opens up or down. So whichever one you end up feeling more confident about, I would say that's the strategy you should use. So here's kind of a outline, step-by-step outline of how we work through a quadratic inequality and solving it. There are some things I want to point out here. We do need to make sure that our inequality is in standard form. Most of the time it is in standard form, but once in a while it's not, and so we need to use our math skills to get it into standard form before we did anything else. Once we have it in standard forms, we are going to find the roots, which remember is a word that means the same as zeros. So we are going to find the roots or zeros of the function. Then what we're going to do is we are going to create a number line that's actually like a little fake x-axis that includes those roots or zeros. So this is going to be like an x-axis. And this is what we're going to work with. It'll have now 3 sections in it created by the zeros or roots. We're going to figure out whether each section produces positive numbers or negative numbers, and I'll show you 2 ways to do that. And then we'll learn how to interpret that to write our solution. All right, let's take a look at this problem. So here's the inequality that we're going to solve. Notice in our instructions it says we have to write the solution as an inequality. That's with our less than, greater than symbols. And we also want to write that same solution in interval notation. All right, so we have this quadratic inequality. The first thing we need to do is find the roots or zeros of the related function. So we take our quadratic, and we know that when we find roots or zeros, we have to be equal to 0. So we take our x squared plus 2x minus 24 and set it equal to 0. Then we're going to do our factoring. So here our GCF is 1, so we'll go and factor into binomials now. And here you might be able to see the binomials we're going to need pretty quickly. But this has to be x and x, and we need 2 factors of -24 that'll add up to 2 in this case, which would be a +6 and a -4. You should always check your factoring to double check and make sure it's working. Like x times x is x squared. This gives me 6x minus 4x, which is my +2x in the middle, and 6 times -4 is -24, before going on to the next step, which is to use your zero product property. So now we know that either x plus 6 has to equal 0, or the x minus 4 has to equal 0. Solving each of those, for the first one we subtract 6 from both sides, giving us x equals -6, and for the second one we must add 4, giving us x equals 4. All right, so now here's where things are about to get different. So our second step is to draw ourselves this number line that's going to be like a fake x-axis. And on this number line, we want to graph or plot our zeros, -6 and 4. Make sure that you put them in the correct numeric relationship to one another. Whichever one is smaller should be to the left of the other one. So -6 we know is smaller than 4, so -6 should be on the left and 4 should be on the right, and those are our zeros. All right, so now I am going to show you the first way that we can figure out, we have 3 sections or intervals now, and we have to figure out whether they produce positive or negative y values, so these x's. So one way is to find where the number 0 is on this number line, or fake x-axis. So we know that 0 is between -6 and 4. And what we're going to do is we're going to test the quadratic. So we're going to test our x squared plus 2x minus 24 to see if we get a positive number or a negative number when x is 0. So that would be like doing, okay, what is 0 squared plus 2 times 0 minus 24? This is why I like using 0, because 0 math is so easy here. This is just 0 plus 0 minus 24, which is a negative 24. So, oh, that's a negative number. So that tells me this middle section of x's produces negative y numbers. Now here's a nice trick that we can use, because we could like pick a number over here like -7, -8 and do the math again, and pick a number over here like 5 or 6 or 7 and do the math again, but those numbers are not as nice to work with as 0. So here's a nice trick that we can use. Turns out when a quadratic has 2 zeros, that it always alternates between positive and negative. So if it has a negative in the middle, its two outsides have to be positive. So there are two options. If we're looking at this situation, we have positive, then negative, then positive. Or if our parabola opens down, then we have negative, positive, negative. But either way, it alternates between the two types of values. Positive, negative, positive, negative, positive, negative. It always alternates. So we can use that fact here. So if we now know the middle is negative, then we know that this side has to be positive wise, and so does this. So it alternates, positive, negative, positive. So now, the other way I can figure out my number line is to draw or graph the parabola. So we have our little fake x-axis with our zeros on it. Now this requires that, again, we use another piece of prior knowledge, some of our earlier learning, that tells us whether the parabola opens up or opens down. And that is dependent on the a parameter, which is the coefficient of the x squared. So here it's a 1. When your a is a positive number, there is no x-axis reflection, which means your parabola opens up and passes through your zeros. Whenever a is a negative number, that means there is an x-axis reflection, and your parabola opens down, passing through your zeros. Here a is positive, so we know our parabola opens up like this. So this piece on the left is above the x-axis, so it's positive values. The piece in the middle is below the x-axis, so it's negative values. The piece on the right is above again, so it's positive. So notice you get the same result, positive, negative, positive, as we did up here, positive, negative, positive. So you can either use the calculation method or you can use the drawing the parabola method. Does not matter to me, as long as you justify your answers with one of these two ways of doing your work. So now we're going to learn how to interpret this number line with these positives and negatives on it and write our solution. And we have to write our solution in the two different ways. And you have to make sure you know which way is which, because sometimes you're asked for only one way to write your answer, inequality or interval notation. And so we have to know which one is which. But first, before we get to that, how we figure out whether we are looking at the positive sections for our solution or the negative section for our solution has to do with understanding what this means right here. So this again is a situation where we need to know our less than, greater than symbols and which one's which. So we have to know that this means greater than 0. Numbers greater than 0 are positive numbers. That means our solutions, our x solutions, will come from the parts of our number line that we determined are positive. So we want the positive sections, which are here and here on the outsides, here and here on the outsides. So we get the same result no matter what. Now we have to be able to write them. So we're going to take a look at our inequality notation. So we have two separate sections. So we're going to have two separate inequalities. This part on the left is always numbers that are smaller or less than this first 0. So this would be x is less than -6. These numbers over here on the right, numbers to the right of a number, are always larger or greater. So these numbers would be x's that are greater than this number, which is a 4. And so in the inequality notation, we connect those two pieces with the word or. So we have x is less than -6 or x is greater than 4. Same thing here. So how we write it doesn't matter which work we've used. It would be the same notation because it means the same thing mathematically. Then looking at our interval notation. So we have two sections, we have two intervals. The interval notation, remember, goes least to greatest and starts over here at the far left where x is at -infinity. So this interval here goes from -infinity to -6. And this interval, least to greatest, goes from 4 all the way to the right, which is +infinity for x. And so we connect our two intervals, remember, with our union symbol. So we have -infinity, -6 in union with the interval from 4 to +infinity. And that completes our solution for the problem. All right, so let's take a look at another example here. So here's our inequality that we are going to solve. So the basic process or steps are the same. What is different is, we have to, for each and every problem, we have to, in our third step, or in our second step, set up our number line correctly, our fake x-axis, and then in the third step we have to always interpret that number line that we create. First step is to find our roots or zeros. So we have our quadratic and we set it equal to 0 to find those zeros, which are also called roots. So once again, we have a trinomial with a GCF of 1, so I would look at factoring into two binomials. What's a little different about this one is now we have a 2x squared. So we have to deal with the factors of 2 also. 2's prime, so we know we have to use a 2x times x. So one of our binomials starts with 2x and the other with x. And then we need two factors of 12, and this time we can't use the shortcut that they'll add up to 11 because whatever we put at the end is going to be multiplied by that 2 up there. So we have to consider what our options are. We have 1 and 12, 2 and 6, 3 and 4. And this is where we have that guess and check strategy. We'll guess which one we think is going to work, and then we'll check it to see if it does. Now I would say 2 and 6 wouldn't even bother trying because 2 and 6 have a common factor of 2, and remember that our binomials shouldn't have any GCF other than 1, so putting a 2 or a 6 in the spot with a 2x creates a GCF that we don't have. So I'm going to think it's probably the 3-4 combo. And again, I wouldn't try the 4 here because 4 and 2 have a common factor of 2. So I'm going to try a +3 and a +4. Then I'm going to check it. I'm not going to assume. So this gives me 8x plus 3x, which is a positive 11x. So that's good. And then I've got 2x times x, which is 2x squared, and 3 times 4, which is 12. So those are my factors. So now I use my zero product property. 2x plus 3 equals 0, or x plus 4 equals 0. Now remember with the first one, that reverse order of operations requires that we undo addition or subtraction first, then undo multiplication. So we must subtract 3 first, and then we get to divide by 2. No options there. It is also very helpful to know what mixed number -3/2 is equal to, so we know, which one of our two zeros is the larger number or which one is the smaller number. Just in case some of you don't quite recall how to do that, it's a simple division. So we'd look at taking 3 divided by 2, and so 2 divides into 3 once. That's our whole number portion. And then we get a remainder, and our remainder of 1 over the 2 is our fractional part, and it would be negative because, well, our fraction is negative, so it's -1.5. And if you just knew that by looking at it, that is excellent. And then for our other one, we're subtracting 4, and so we have x equals -4. All right, so now into that step where we draw a number line that's going to represent a little fake x-axis. And we have to know that -4 would be smaller than -1, because in the negative direction we count backwards. So -4 is somewhere there, -1.5 somewhere there, and these are our zeros. All right, now here we have our two options. We can test our intervals, choosing a number to plug into our quadratic, or we can draw the parabola. I'll do both ways again. So I'm going to do my calculation strategy this time. So I want to know, where is the number 0 on my number line? And 0 would be over here this time because it's bigger than negative numbers. And so I'm going to take 2 times 0 squared plus 11 times 0 plus 12. Again, 0 math, nice and easy. 0 plus 0 plus 12 is 12, and 12 is positive, so that tells me this section over here where the 0 is located is a positive section. Because quadratics alternate when there are 3 sections, I know the middle has to be negative, and this outside over here on the left also has to be positive, so we get positive, negative, positive, alternating. Or, remember, our other method is to draw our little fake x-axis, put our zeros on it, and then draw the parabola. And for that, we need to know the value of a. So a is that positive 2. So again, a is positive, which means there's no x-axis reflection, which means our parabola opens up, like so. So the left piece is above our x-axis, so it's positive. The middle's below, so it's negative. The right piece is above, so it's positive. So we get the same result, positive, negative, positive, as we do with the calculation method. So now is the big third step, is figuring out and learning how to interpret this number line, whichever one you created, or if you create both for your notes, that's a good thing. So now we want to write our solution, but when you do your homework, step 2 can be one or the other. So let's look at our inequality. But before we can write this, we need to know, well, is our solution the positive sections on the outsides or the middle section, which is negative? And we do that again by knowing what this means here. Does this mean greater than 0 or less than 0? So this one looks most like an L, and so this is our less than 0. And less than 0, numbers that are less than 0 are negative numbers. So this is telling us our solution is any section on our number line that is negative, and that is our middle section this time. So this section is our solution section. So remember, for the inequality, this middle section is bounded by the smallest number of -4 and then the biggest one of -1.5. So we start with -4, which is less than all the numbers in the middle we call x, and the x, the numbers in the middle, are all less than this 0 of -1.5. Same thing, of course, here. And so that is our inequality notation. -4 is less than x, and x is less than negative 1.5. The interval notation, we had one section, so we have one interval. One section, one inequality, one section, one interval. And that interval is bounded least to greatest by -4 and -1.5. So it gets written like that. And finishes up that one. All right, we have one more example to go through together. Let's look at this one. So here is our quadratic inequality. All right, so we're going to start the same way. Very first thing we're going to do is find our roots or zeros. And so we take our quadratic, -3x squared plus 10x minus 8, and we set it equal to 0. And we're going to start our factoring. Now, the strategy I encourage everybody to use when your leading coefficient, your coefficient of x squared is a negative number, is to factor out -1 as a GCF. You don't have to do that, but it does make the rest of the factoring easier because it will change the signs and we'll be able to deal with a +3 instead of a negative for the binomials. Trying to factor binomials with negative x's is challenging for a lot of people, including me sometimes. So I like instead to factor out -1 as a GCF. And all that will do is change my signs. So -3 becomes +3x squared. +10 becomes a -10x. And then minus or -8 becomes a +8. The nice thing is, since zeros only come from x parts, we're going to be able to ignore that -1 later on because it has no x with it. But now let's keep it for now and do our two binomials. So here we have a 3x squared. 3 is prime, so its factors are 1 and 3, so we have to have a 3x times an x. So one binomial has to start with 3x and the other with x. And then we need two factors of 8. And we need to figure out which are going to help us to get this -10. And since the 10 is negative, remember, we're going to want to use negative factors of 8. So we could use -1 and -8, or -2 and -4. And then we kind of guess and then check until we find what works. So I'm thinking that the -2 and -4 is going to work, and I think we want -4 here and -2 there. And then checking, this is -6x. Plus -4x, -6 plus -4 is -10, so it works. So now we use our zero product property. And here's where the -1, which doesn't involve x, can't be equal to 0, so we just ignore it. But the other two do involve x, so we're going to get the zeros from those. So we have 3x minus 4 equals 0, and x minus 2 equals 0. So once again, with this first one, we have to undo this subtraction first. So adding 4, we get 3x equals 4. Dividing by 3, we get 4/3. And again, it is a good idea to know what that is a mixed number, which would be 1 and 1/3. And if you need to, you can do the division. That 1 right there is our whole number 1. And the remainder over the divisor of 3 is the fractional part. Then this one, add 2, gives us x equals 2. So now we can see that when we make our number line in the second step, which is our little fake x-axis, 1 and 1/3 is smaller than 2. So the 1 and 1/3 needs to be on the left side and the 2 on the right side. So now you have those two options for figuring out which sections are positive and which are negative. One you can do by calculation. So find where 0 is on this number line, which would be over here somewhere. Plug it into your quadratic. So we have -3 times 0 squared plus 10 times 0 minus 8, which is 0, plus 0 minus 8, which is -8. Oh, that's negative number. So this left section is producing negative numbers. And then remember the alternating. So if this section here is negative, the middle must be positive, and the right must again be negative. So it alternates between negatives and positives. If you prefer the method of drawing the parabola. You still got your little fake x-axis and your zeros. And to draw the parabola correctly, you need to know the value of a. So again, a is the coefficient of x squared, which is -3. Because our a is negative this time, we do have an x-axis reflection, which turns our parabola upside down. So now it opens down, like so. And so we see this left section is below the x-axis, making it negative. The middle is above, making it positive. And the right is below again, making it again negative. So same result, negative, positive, negative. So now we are to the third step where we determine which sections belong to our solution, the positive section in the middle or the negative sections on the outside. And that is determined by understanding what our inequality here means. So we have to know that this means less than 0, and that numbers less than 0 are negative numbers. So this is saying the negative sections are the solution sections, and they are the ones on the outside. So over here on the left, these would be x's that are less, smaller than the 1 1/3. Over here to the right, these would be x's that are larger, greater than the 2. And so for our inequality, we would connect those two pieces with the word or. So we have x is less than 1 1/3, or x is greater than 2. And then our interval notation for these outside pieces, the left one starts at -infinity for x and stops at the 1 1/3. The right one starts at the 2 and goes to positive infinity for x, and they're connected by our union symbol. So we have here -infinity to 1 1/3 in union with the interval from 2 to positive infinity, like so. All right, next I do have a practice problem for you to try. So I encourage you to pause the video, give this practice problem a try, and then turn the video back on or start it again when you're ready to check. So here is our practice problem. All right, let's take a look at the final solution. So, oops, that wasn't supposed to happen. Here we go. So here's our first step of figuring out our zeros, our roots. Here is our second step of making our little fake x-axis with our zeros on it. And then here, this shows the parabola drawn, which opens up because a is +1, so there's no x-axis reflection. If you tested with 0, 0's in the middle this time, so that would give us 0 squared minus 5 times 0 minus 6. 0 minus 0 minus 6 would be -6, which is negative. So notice it matches. And then alternate, so positive, negative, positive. And then it's interpreted by understanding that this is our greater than 0 meaning, and numbers greater than 0 are positive numbers. So those positive sections create our solution sections. So on the left, we've got x is less than -1, or on the right, x is greater than 6. All right, that does finish up this lesson. I hope you have a lovely, lovely day. Bye-bye.